All right, what's up, everyone? This is Mr. Chang back at you with another week of math. Welcome to your new unit. We are doing trigonometry, and I hope you guys realize that given the new circumstances, the amount of workload teachers are giving you should be pared down to what you really need in terms of getting yourself prepped for the next year. And we're not really trying to burden you guys with work and stuff like that, just enough so that you can get the practice in and get the skills in. And then you guys will just show us by quizzes or by little assignments, just whether you've got these expectations met or not. And really, it's just all about that. Here we go. We're going to talk about today in our trigonometry unit, the very first thing, which is solving sides and angles with trig ratios. Okay, so the goal here is to use the three trigonometric ratios to solve unknown sides and angles in right triangles. And I've got for you the steps for solving sides and angles of right triangles with trig ratios. Number one says label the sides of your right triangle as hypotenuse, and I underline each YP because that's what I would write on the triangle instead of the full word, adjacent and then opposite. So you do it in that order, because if you do it in that order, you save yourself that very, very common mistake where students mislabel the triangle and everything else goes to garbage because they use the wrong formula and they get the wrong answers. Then, if you're solving for a missing side, you have to identify a given angle inside, that's the highlighted yellow, or you're going to be solving for an angle, which you follow the highlighted blue, and you identify your two given sides. You select the appropriate trig ratio that involves all three of your values. That's the missing side or angle and the two other parts, right? And then you substitute and solve in. Okay, let's see. So here I've got the three basic trig ratios. So, ka, toa, that's how they're known, right? Because you write them in this order where you start with so is sine, and then opposite, and then hypotenuse. It's always 1, 2, 3 in that order. Okay, so you'll see me do, so is so like that. Ka, C-A-H, and then toa is T-O-A. Always just follow that order and write out your formulas. Okay, notice that in each formula there are three different parts. Okay, right there. You have to have the theta, the adjacent, the hypotenuse. If you're doing cosine, the theta, opposite, and the adjacent. There's three different parts. A lot of people leave the theta out and they just write it as like sine, opposite, hypotenuse. They don't write the theta, and the formula is no longer useful. All right. Just remember that there are three different parts. So one more thing I want to say before we really get cracking at it is in the side view, if we're talking about word problems, quite often word problems will discuss things in side view. When you're looking at something at the side and you're looking at 3 points, right? It could be 3 objects and so forth, and they'll use the terms angle of elevation and depression. Okay, and it's very important to understand here, if I'm talking about angle of elevation, the first thing you got to do is you got to recognize where the horizontal line is. And once you have the horizontal line, if we are talking about an angle of elevation, we are going up by a certain degrees. Okay, and there's the other object up there. Okay, the angle of elevation questions will give you the angle inside the triangle. Okay, so in this case, if I told you the angle of elevation is like 30 degrees, then guess what? That goes right there. Okay, easy. However, on a flip side, if we were talking about angle of depression, notice what happens here. The angle of depression is a man looking downwards into a bit of a ditch at his dog, let's say, and you can see you have to start by going again at the horizontal, right? And here's a horizontal, use a different color, there you go, horizontal, right? He's coming in with horizontal, and he's looking down at his dog at an angle of depression. Let's say this angle of depression is 50 degrees, right? So he's looking downwards at 50 degrees at his dog. That goes here. And notice that the angle of depression is actually, it turns out to be outside. Okay, so the angle here is outside the triangle. That's important to know, because if you recognize that the angle is outside the triangle, then you can just go ahead and build your triangle like this, and the 50 degrees, even though it's outside, it occurs on the inside here, like that. Okay, so that's something, if you remember, as alternate angles. You would have learned that maybe from before. You got an angle here and an angle here, right? If it's 50 here, then it's 50 here, because these guys were parallel lines to start with. All right. So good. Let's talk about some examples. We're going to start off with some knowledge-based ones where we just work out calculations for sides and angles, and then we're going to look at a few word problems. So let's go. For the following triangles, solve for the unknown side and round to the nearest tenth. So you'll see here, I've got a triangle right here, and I'm looking at it, and the first thing to do, remember step one, let's just pull back at it. Step one is you want to label the sides of your right triangle as hypotenuse, adjacent, and opposite. Okay, so let's do that. In this case, the hypotenuse, if this is the 90 degrees, it should have been drawn, but it wasn't, so fill that in, is always opposite from the right angle. So across from the right angle. Okay, so this is our hypotenuse. You always label that first. It's the longest side. Quite often it's easy to spot, but it's directly across from the right angle. Then, once you spot your angle, okay, we are going to be talking about one of these two angles, not the 90 degrees, but from the reference point of one of these two angles, you have an adjacent side. Adjacent is another word for B-side, standing adjacent to someone or beside an angle. So in this case, adjacent is right here. Lastly, opposite is the side that's directly across from your angle. Okay, and that's opposite. Imagine if there's an LCD projector, you shine it on the wall right here. Okay, good. So that's opposite. Once we got it labeled out, we figure out which two sides we need. Well, I'm going to tell you, we need the adjacent side because that's the x there. We're going to use the hypotenuse side because that's the value there, and we're going to use this angle here. Okay, in terms of this opposite side, we're not going to use it, so I am now going to cross it out so we don't get mixed up into it. So what trig ratio, because we need to select one, uses adjacent, hypotenuse, and an angle? The answer is CAH, C-A-H. Okay, so to fill this out, we are going to write it out properly. So cosine of theta is equal to adjacent over hypotenuse. And let's continue on. That means that the substitution phase should look like this. Cosine of theta, which is 30, is equal to the adjacent, which is our x, and our hypotenuse, which is 15. Okay, now in this case, we're trying to find this x value, and so we got to isolate x. And the only way to really do that is we have to multiply both sides by 15. Because the x is being divided by 15. If we multiply both sides by 15, these 15s will cross out, giving me the x all alone, which is what I want. Okay, but what happens on the left side, what you have to do is on your calculators, set to degree mode. Make sure you have, it says degree on the top there, where there's an indication of the capital letter D, not a capital letter R or RAD, which means radians. That'll give you messed up answers. So make sure it says degrees, and you're going to write 15 or type 15 times cos 30 and hit equals, and you should get what I got, which is 12.99. And you know, we're talking about the nearest tenth, so we got to round it to the nearest tenth. So if I do that, that'll be 13 equals x. Okay, and there's my answer. X is equal to 13. I'd include units, but there are no units. And that's that. Okay, so let's continue on. Let's have a look at the next one over here. And this diagram gives us everything we need again. So we are looking at it. We got an angle. We got a hypotenuse right here. So let's just take a moment and fill this stuff out. I think I can move this stuff for us too. Just bring it off to the side more. Put it there. Better. Okay. So we got hypotenuse, and we got adjacent, and we got opposite. And just looking at it, I need this angle. I'm trying to figure out this, which is my hypotenuse, and I also have the opposite over here, which means I don't need the side which is called adjacent. And so looking at it here, this is a setup where I have O, H, and theta. Which one of these trig ratios has the O and the H? And the answer is SO, S-O-H. You see that? Sine is the function, and we got opposite and hypotenuse being used. So let's plug in all of our values. So let's write it in. Sine theta is equal to opposite over hypotenuse. Let's start with the formula first, and then second step is substitution. So sine of theta, which happens to be 60, is equal to opposite, which is 12 centimeters, right, over the hypotenuse, which is x. Now, if you notice, in this particular case, the x is on the bottom, and we can't just get it in one step out because, frankly speaking, when you're dividing something by x, you're going to have to multiply both sides by x, okay? And you're going to take that time, multiply both sides by x, and then divide both sides by sine 60. Really what that does is it allows you to just switch these two, okay? And this is a little thing that I call a monkey wrench. It allows you to switch something on the outside, on the left side here, with something on the bottom of your fraction. They can just switch, and you can rewrite it, okay? Because that saves you all those steps. Very useful. And now you just come in with your calculator and go 12 divided by sine of 60, and you get 13.85, which we're going to round to 13 point, one decimal place, 9, and we got to use units in this case, so centimeters. Okay, I'm going to pause it for a second. I want you to try to label out this triangle and sub it into the correct formula and see what you get. Well, did you do this much? Hopefully you did. Labeled, chosen TOA or tan, subbed in, got something that looks like this. Let's just take it home right now. I'm going to switch with the monkey wrench, right? And this will now look like this. If I draw a little arrow here, it'll look like x is equal to 10 divided by tan of 20, because that whole tan 20 goes underneath. Let me fix that 20, make it look clean. And 10 divided by tan of 20. Looks like it's 27.47 or 27.5, okay, because we've got to round it. And there's our answer. Great. So that's how you do it with sides. What if you had an angle?